Good morning students. From chapter 5 geometry, today we are going to see Pythagorean theorem, or we simply called as Pythagoras theorem. Pythagoras' theorem is named after a Greek mathematician Pythagoras. It's definitely one of the most famous and celebrated theorems in the whole of mathematics. In this theorem, let us consider a right angle triangle. The side which is opposite to right angle, that is 90 degree, is the longest side of the triangle, and we name that side as hypotenuse. The theorem stated that the square of the hypotenuse is equal to the sum of the squares of other two sides. That is, the other two sides we call it as the two legs of this right angle triangle, and we named as A and B. According to the statement, we can write h square is equal to a square plus b square, where a is the hypotenuse, h is the hypotenuse, and a and b are the sides of the right angle triangle. Let's prove this theorem by considering the example. Here we are considering a is equal to 4 and b is equal to 3 and h is equal to 5. First we are finding out the hypotenuse square, that is h square equal to 5 square, which is 25. Then we are finding the squares of other two sides, that is a square plus b square. A is considered as 4 and b we are considered as 3. We get 4 square plus 13 square as 25. Comparing these two, we can see that h square and a square plus b squares are equal. Therefore, h square equal to a square plus b square. Or, if we give the name for the triangle as A, B and C, instead of h square, we can write BC square. Since the distance between BC is the height, therefore BC square equal to AB square plus AC square. That is, the Pythagoras theorem stated that in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares on the other two sides. Let's see the converse of Pythagoras theorem. The converse is, if in a triangle, the square on the greater side is equal to the sum of the squares of the other two sides, then the triangle is right angle triangle. Here we consider this triangle ABC. AB is given as 11, BC is given as 61 and AC is given as 60. The converse is square of the greater side is equal to the sum of the squares of other two sides. Here the greater side is 61 and the other two sides are 60 and 11. If you find the squares for these two, we get 11 square plus 60 square as 3721, which is the square of 61. That is, we can write 61 square. But 61 we taken for the side BC. 61 square can be written as BC square. That is the greater side square. That BC square equal to AB square plus AC square. Since they are equal, we can say this triangle ABC is a right angle triangle. Let us see sums from exercise 5.2 using Pythagorean theorem. Check whether given sides are the sides of right angle triangle using Pythagoras theorem. They had given 8, 15 and 17. First we are taking the sides A to be 8, side B as 15 and side C is equal to 17. Since 17 is the greater side, we have to find out the squares of these two sides. That is a square plus b square, which is equal to 8 square plus 15 square, we get 289. And of the square of the greater side, that is c square equal to 17 square, also we get 289. These two are equal, therefore a square plus b square equal to c square. By the converse of Pythagoras theorem, the given measures is a right angle triangle. The next sum, 12, 13 and 15 are given as the sides of the triangle. You have to prove that whether these sides can form a right angle triangle. Here also we are taking A to be 12, B as 13 and C as 15. First we are finding the value of c square. Since c is the greatest side, so we are finding the c square. C square equal to 15 square. The value is 225. The sum of the other two sides, that is a square plus b square equal to 12 square plus 13 square, and we get the answer as 313. This is not equal to 225. That is a square plus b square is not equal to c square. Therefore, again by the converse of Pythagoras theorem, the given measure is not a right angle triangle. Next, fourth sum, find the unknown side in the following triangles. Here the triangle ABC is given. Also they had given the angle A as 90 degree. Since one of the angle is equal to 90 degree, then we can say this triangle is a right angle triangle. It is given in the right angle triangle, so we can use the Pythagorean theorem. We know that Pythagorean theorem, the hypotenuse square is equal to sum of the squares of other two sides. Here the hypotenuse is given as x and the other two sides are given as 9 and 40. Using this theorem, we are going to find out the value of x. From triangle ABC, we can write BC square equal to AB square plus AC square. BC is given as x and AB and AC are given as 40 and 9. Substituting this, we get the value of 1681. This can be written as 41 square. That is x square is equal to 41 square. That means x equal to 41. Therefore, the unknown side is 41. Let's say another example in the same model. Here the triangle PQR is given and they had given the angle Q as 90 degree. Since it is a 90 degree, then we can say this triangle is a right angle triangle. If we are having the right angle triangle, there we can use the Pythagorean theorem. According to this theorem, the hypotenuse square is equal to sum of the other two sides. The side opposite to the right angle is the hypotenuse side. That is, from 90 degree, the side opposite is PR. Therefore, PR square is equal to PQ square plus QR square. PR is given as 34 and RQ is given as 30 and PQ are given as Y. That is 34 square equal to Y square plus 30 square. From this, we are going to find out the value of Y square. Y square equal to 34 square minus 30 square, we get 256. Through 256 is the squares of 16. That is y square equal to 16 square. Then y equal to 16. Therefore, the value of the unknown value y is 16. Let's see one more sum. An isosceles triangle has equal sides each 13 cm and a base 24 cm in length. Find its height. Here they had given an isosceles triangle. We know that in isosceles triangle, any two sides of the triangle are equal. Here we are taking A, B, C and we take AB and AC as an equal sides and it is given as 13. That is AB is equal to 13 and AC is equal to 13. And they had given the base to be 24 cm. That is the base BC is 24 cm. Since it is an isosceles triangle, to find the height of this triangle, you have to draw the altitude from angle A. If we draw the altitude from angle A, then it bisects the base BC at its midpoint at 90 degree. Then we get triangle ADB as a right angle triangle. It is a right angle triangle. To find the height, that is AD is the height of the triangle, you have to use the Pythagorean theorem. The right angle, the hypotenuse side is AB since it is opposite to this right angle. Therefore, AB square is equal to AD square plus BD square. AB is given as 13 square. You have to find the height AD. Then to find BD, this altitude bisects BC at midpoint, so it divides into two equal halves. That is BD is 12 cm and DC is 12 cm. AD square equal to 13 square minus 12 square, we get 169 minus 144. Then we get AD square equal to 25. 25 can be written as 5 square Therefore, AD equal to 5 centimeter. That is, the height of the triangle is 5 centimeter. Thank you.